show that formulas are true, we do not plug in numbers, and the reason for that is because we want to talk about the behavior in general. The idea is if you plug in numbers, you don't get an argument that's going to work in general. And because it's a bit tough to explain, it can be done without plugging in numbers for exponential formulas. But the explanation is rather difficult to say on paper. And so the one exception for true formulas is you may plug in for exponents. So do not plug in for the base. Again, in general, for true formulas, plugging in numbers is never the technique. The one exception is for exponents. And so to show these two true formulas, a to the m times, even though there's no time sign, a to the m times a to the n equals a to the m plus n. And to show this formula, a to the m all raised to the nth power is equal to a to the n times n, even though there's no time between that m and n. To show this, let's plug in 2 for m and 3 for n. You can choose other numbers, just don't choose 2 for both m and n. That's the only problem. So then here, the a to the m times a to the n is equal to a to the 2 times a to the 3, which is a times a. That's the a squared formula. Then there's this sign. I'll draw a couple of arrows here so that it's clear which symbol is which. And then I still have a cubed, and that's going to be a times a times a. So in total, I have a times a times a times a times a. That's exponentiation or repeated multiplication. That's a to the fifth, which is our example of a to the n plus n. Again, in general for true formula, plugging numbers is not allowed. So the argument can be made without plugging in numbers for m and n. It's a bit easier to do this one with numbers. So this is the only exception. You may plug in numbers for this formula, just for the exponent, and this formula for the exponent. We'll go ahead and use the same numbers. You could use numbers, but I'll go ahead and use m is equal to 3. And so a to the m quantity to the n is a to the 2 to the. So something cubed. Well, I have a squared times a squared times a squared. I took care now of what it means to cube something. And now I should peel apart a squared as meaning a. Okay, there's this times sign here. Then I have a squared, which is again a times a. Now let me write this times sign right here. A times a. And in total, this is a to the 6th. Because I've got a times a times a times a times a. Again, exponentiation is repeated. And this is our example of a to the m n, right? A to the 2 times 3 is 6. These two are actually not the only formulas where you would plug in a number. I'll just point out the one and only remaining formula in this class for which you would be plugging in numbers. So for true formulas, plug in numbers for the exponents here, plug in numbers for the exponents there, and there's one last formula. I just thought of it. So if you have a over b raised to the nth power, this is equal to a to the nth over b to the nth. For this true formula, you will also plug in numbers for the exponent. Let me go ahead and use n is equal to 4. So then a over b to the 4th means a over b times a over b times a over b times a over b. And you have fractions. So we saw earlier that for fractions, you just multiply across. Do not cross multiply. So a times a times a times a for b times b times b. We reinterpret. Remember that exponentiation is repeated multiplication. We have a to the 4th for the numerator. This b to the 4th, that's here in the denominator. We can instead write b times b times b times b. We can rewrite as b to the 4th. Again, just to remind you, this formula right here, and this formula right here are the only formulas in this class where you would be allowed to substitute for variables, and even then, not every variable, just the exponent and not for the base. Again, plugging in numbers is generally not to be used. This is just the one exception, just because the explanations otherwise are really weird. Just remember that for false formulas, you should plug in numbers. And for true formulas, each formula has its own argument in general, which is why there's these videos where you can review what we have done in class.